Introduction to structural design. What we are looking here is a beam in green color that has some loads in gray, is sustained by two columns, and the red line is the deformation that this beam is subject because of the loads. And in the inferior part, we have the diagram of this deformation. That is what we'll be doing this semester in the first weeks. We will study a review of structures 1, some important concepts, and beam calculations. First, we have some important definitions. Mechanics, that is the branch of mathematics that deal with motion and forces that produce motion. Mechanics can be divided into parts. One is statics, that is related with bodies at rest and forces in equilibrium, and dynamic, that is related with forces that are in motion. Statics are non-moving bodies, like buildings. Dynamics are moving bodies, like some machines. Structural elements can be classified, and that depends on the geometry, the stiffness, the fact that there are one-way or two-way systems, and materials. There are primary structural elements, and the most important is the simple system of a beam and a column. It's not anything complicated. It's just a frame where a beam is supported by columns and the forces are transmitted to the ground. Frames are rigid systems of beams and columns. We have also trusses. Trusses are a little bit more complicated. It's a structural element usually made of straight pieces, metal, timber, and they create a series of triangles. Usually they lie in a single plane, and they allow to support spans that are very big and loads that cannot be that heavy. Arches are typical curved structural elements and has been using since a long time ago. There are other structural elements like walls and plates, cylindrical shells and bolts, shells, domes, cables, membranes, nets, etc. All these structural elements are part of what is the nature of a structure. The nature of a structure is a balancing act. I mean, the resistance of the structures versus the force of the nature that make a human space that will not exist unless and until it's enclosed by a structure. Structures are everything that we construct. Everything that we construct have a nature. And in the case of a structure, we will have that the structure, even if it is made by many elements, need to work and function as a whole element. It's designed in response to loads that we can anticipate, but it's very fragile for loads that are unanticipated. Therefore, the definition of a structure will be anything that is constructed or built from different interrelated parts with a fixed location on the ground. There are three main considerations when we design a structure. One, stability and equilibrium. That is the balance between the different forces. If the element is not stable, will tend to move, and that is not convenient. Strength. The structural building must not break, cannot collapse, need to be strong enough to support the forces that are acting on it. And finally, toughness or functionality. Some buildings, it may have some inconvenience, like they move, like they deform. They still strong, they still stable. But when a building deforms too much, people can be afraid to use it, even if the building is safe. Well, it's important that work well and is tough enough. Many times you have been in a bridge, that the bridge is moving a little bit, or in a big parking building. When there are not loads, I mean a lot of cars, and you walk in a parking building, maybe you will feel that the floor move a little bit. If that movement is very strong, that is not convenient. People will be afraid, even though the building can support the weights and the loads. Well, we need to consider also that the structures must receive loads as a gravity, wind, vibrations, impact, earthquakes. And sometimes it's not enough that the calculations work to support all the loads. We need to exaggerate a little bit the calculations because there are safety factors. We need to make sure that the building supports the load and any other exaggeration or accident that can happen. And that's what is called a safety factor. Also, we need to consider the behavior of the material. So material will deform under stress and may deteriorate. When we design a structure, what is the problem? Some people will tell the efficiency. The structure needs to be very efficient. The other people will tell, no, it needs to be interesting, innovative. There is no right answer. What is true is that we don't need so many structural skills to design a building that stand up. For example, a beautiful temple, it can be very well made, it can be very well designed, it can be full of details, but not necessary is a structure that requires strong structural skills and calculations, like a pyramid, for example. However, when the space is large, we need more structural efficiency. And then it's very important to think about that. There are some very interesting buildings that have very good and innovative structures, at least in the moment that they were made. One example is the Bank of China in Hong Kong. You can look here that it's like a truss that is all around the building. The Sydney Opera House also was a very innovative building. The Centre Georges Pompidou in Paris has something very interesting. In the interior, there are no columns. All the columns are in the outside of the building, as well as all the circulation and all the services. All the central area of this building is free to do whatever the designer wants to do. The High Court of Australia have very interesting columns in the interior parts. The Sydney Bridge in Australia is a bridge that at the same time that have like a big arch, the arch is made out of trusses, and the elements where the cars are passing through are just hanging from that particular arch. I mean, the deck is hanging from the arch. Well, finally, what do we want to know? Well, first, what is a structure and what the structures do? And that is to enclose the space. What we are trying to do to prevent the failure of that structure. That is through equilibrium, strength, and functionality. You can look here some interesting buildings that were made in a way to be not only beautiful, but structurally significant, like the Staatshof in Leipzig, the Harpa Concert in Reykjavik, and the NRD in Toronto, Canada. What caused failure? Loads, insufficient support, inadequate arrangement of the pieces. We can have enough pieces, the supports are sufficient, but if they are not in the place that need to be, that is a very big problem. Also inadequate strength, size, materials, also inadequate stiffness.